Okay, I'm here. So microphone seems to work. Let's see. We need a chat somewhere. Okay, that will do probably. All right, let's put that here, and I want to go here and say notifications, enable text-to-speech, do not read links, read emojis. Okay. All right. Probably let's update the title a bit because it's not correct entirely. So update titles. So ButtonBox case design, RP2040 hardware, fun. CLion, let's see. There you go. Update. Okay, looks good. Looks good. And let's check. Let's check Twitch. Okay, looks also good. Perfect. So let's see. So the goal is to take this design that I more or less hacked together in Tinkercad and bring it over to FreeCAD so that we have real measurements and can adjust it more easily, because with these kind of, so it's not complicated, right? But it's kind of hard to adjust and you have to move things around. And I think with real sketches and having the tree in FreeCAD, it's probably better for sharing and probably better for adjusting. Also, I have an idea that I can combine two parts. So I want to combine basically the plate here and the plate below that into one. Okay, and I guess we will start with this base plate where the buttons are here, and I can show you the buttons or the button box. The finished assembled button box is here like this, and we can take this apart and remeasure things or just take the measurements from here. I'm not sure yet. Let's see. So first let's go here, and then we're gonna say opening FreeCAD. And it's possible FreeCAD crashes because I installed the beta. If that happens more often, then we will switch to the older version and hope everything goes well. Okay, so let's open a new document and let's save it immediately. Here, create a new folder. There you go. And we call this ButtonBox for now. The goal is to probably have everything in one document. Save. Okay. And then I'd say we start with a new body. And this body will be, this will be the base plate or the button plate. Okay, so we got that, and let's head here. So see, we can't get into it without disassembling everything. And we probably need to do that. So can I create a copy of the whole thing? So copy and paste in place. I can't do that here. Import, export. If I save that here, it will override it. Right, let's go back to Tinkercad. And say duplicate. Copy of ButtonBox, exactly. And now here we can destroy everything. Go ahead. So now first let's start and take this base plate here. This will be tricky because all the mouse shortcuts and everything is basically different in FreeCAD and in Tinkercad. So, okay, so let's first ungroup this. Now we have the holes here. And these holes are pretty good. So let me take a sheet of paper and write down some measurements. So here we go. Okay. Oh yeah, before I forget, I want to turn off that microphone because otherwise you have a horrible echo. So then we can go back here. All right, so one of these negatives here, what we want to know is, okay, so these are just holes, right? And I have smaller holes. Okay, so these consist of basically two things. One is the bigger hole, and I guess we need to disassemble the ButtonBox so you see why this is necessary. So basically here the, I don't know, the stems of the PCB go in, right? And on the bottom you can screw it tight if you like. It's not necessary, honestly, because the whole button plate and the buttons will be pressed down by the upper parts, so by this plate here. So, but anyways, I kind of just kept it as a fallback if I need to make the buttons real screwed in real tight. So we got this here, and this seems to be 3.5 mils. So let me draw one of these. So this is 3.5 mils. And here we go again. We need to disassemble that one as well. And then we can take one of these and check, and I made them 6 mils. So this will be 6. So the whole plate is 130 times 120, not 130, but 100.30 times 120.2. Okay. So this will be I guess this is not really important. What's important is the distance between these things. So, and I'm not sure if that's the final size anyway, because I have planned a place for the PCB and for the RP2040, but so my plan was to put it down here into the box, into the space that you see here. So that was my plan, and it kind of fits, but it doesn't fit perfectly. And I didn't design that part out because at some point we need a USB connection outside, and this will be a bit tricky because I have no clue how to do that, honestly. So what I have I have kind of a clue, but not a real one, not a good one. So because what we have here on the RP40 is here the small USB. It's not a plug, it's the other way, it's the other thing, the USB port, right? So this is fixed and it doesn't stick too much out of the PCB itself, so I can't just place it here and let it basically go through the wall, because then the PCB would be halfway in the wall. So that's weird, right? So I looked for kind of things where a small cable that I can just put here and then have a real socket on the other side. It seems that's the way to go. I don't know. I need to search for that. I never did that. I have no clue. So, right, but that's for later. Right now, what we need to do is get basically this distance here between the four exactly right, because this is basically given by the key, the display key itself. So, okay, and how are we gonna do that? So I guess if I select one of these, right, and then another one, I see here a distance of 23.5. Okay, so if I have this, it's 23.5. So, and these things were 3.5, which is 1.75, right? If I just take half of it. So, okay, I need to subtract half here, which is again 3.5. So it comes down to exactly 20 mils, right? Okay, so from center to center, it needs to be 20 mils. So, and the same here, we take that and this one and then check. This is a weird measure. It's 32.75. So let me write that down, and then we need to subtract again 3.5 from it. Maybe I did it. Maybe it's supposed to be 30 mils exactly. I don't know. So let's see if the others have the same spacing. So if I take this and that, it's the same spacing. And if I take this on that, it's the same spacing. Now let's check one of these here. Yeah. I'm not sure why I did. So if it is 30 mils, it should be overall 33.5, right? So we got 32.75, which is, we're missing 3/4. We're missing 3/4 of a millimeter. I don't know. Let's just put that as a note. So here I have a real measure of 29.25 mils. Okay. Oh, wrong screen. Sorry. So I was measuring these things here. So this should be free probably. So 30 mils 3 centimeters, but it's something else. Okay, so let's write down, because I don't have that, the base plate dimension. So this is something like 100 on the short side and 120 on the longer side. And I just increased it, to be clear, because I wanted to make it fit tightly into the case. But I think in when we redesign it, we can just take this as a base measure and measure the case around it. So that's probably better. So now the second question is, I need these cutouts, right? Yes, I need them. Because the cutouts are for these small things that where I screw the case together. So the screws go so basically here, right? So they go in and then they are tightened inside this. There is no thread in it, no nothing. It's just small enough so that it fits. And if the screw is long enough, then it really holds tight. And we can easily put a metal thing in there so that we can really screw it tight, but that's not for now. Okay, got it. So maybe let's disassemble the thing here. Ooh. So okay, we need this here. So we need kind of a bit holder, and then this is, in German it's called Inbus. I don't know how this is called in English. Probably the same. Yeah, so that's the right one. Okay. And then we can take the support here. So you see, this is the base plate with the buttons. That's the white thing in the design. And I just pressed them in, and I can get one out, right? But it's not that they fall out by themselves. So right, and then you have here these small stems that go in there, and they have a hole and a thread inside. So we could, if we want, tighten them with a screw below. So, and the box is planned like the screws won't get in the way of these small bridges that basically put the whole button pad on a bit of a diagonal so that it's towards you. So, okay, let me get my measure, and then we can remeasure this stuff. Okay. So we got 2 mils, 20 mils here, and I thought it was 30 here, but I designed a different measure. So let's see what you can see. Yeah, you can see it. So I can just screw here. We can display it. So first let's try probably this from hole to hole. So we got between 19 something and 21.4, right? And here we have, so see, it's 28, and on the long axis it's 31. So 30 should be fine, really. So let's go back for a second to here and remeasure. So now we'll be messy here. Okay, and remeasure that thing. So from here to here, we have 23.5. So, and this should be basically the measure when I measure outside, right? So when I measure here, we have 23.10, right? And you can usually squeeze 0.3 or something. The plastic will just give away a bit and it will be just tighter. So, and here we got 22.37. 22.37, and let's look here. Oh, here, but here. Not 22, 32.37. And here we got 32.75. So yeah, it's a bit bigger. Okay. Now, okay, so let's go back to FreeCAD. And most likely we should start with one master sketch where we have most of the measures from top. Right, okay, so let's try this first. I don't know if that works. So We're looking from top, so we want this one. Okay. Let's get some grid lines going. Okay, and let's start with, so let's see. Okay, so let's see. We could go ahead and just use a rectangle and do the cutouts later, or we design the cutouts into it. Okay, no. Let's make it like this. Let's say 100 times 120. Okay, then we say we just want to center it, so we take this and that and say we want a symmetric constraint, the same as here. A symmetric constraint. Okay, so we got that. Now let's head back here and use one of these friends. Either this or that. Not sure if I stored that. It seems I did not. So what I want to know is the diameter of the things down here. So let's turn that 180 degrees. Take this and ungroup it, and probably ungroup it again. Oh no, wait, oh no, on the base plate it needs to go through, right? So let's say we take this here. So here I measured 8 millimeters. Eight millimeters, and I think here on the base plate I have two versions of that. I think, not sure what's different here, but let's ungroup this. I just used a cutout with a radius, so we're not going to do that because I think in FreeCAD we can do it properly. So let's say we want a cutout here. So we could take a circle or an arc, right? Arc from center, that's right. So we go here like this. We say here it's not 8 mils, but There can be space because it will tightly fit on the sides. So for the moment, let's make it 9 mils. Right, what's 0? Okay. And then I should be able to say just here like this. Okay, so we got that. So and probably we want a, oh, and I forgot all about that. We want to have variables for that so that we don't have to remember. Okay, so let's just say okay for a second and go to part design. And here we have check geometry, clone, no. It was somewhere, it was here. We got it here. Variable set creates a variable set, which is an object that maintains a set of properties to be used as variables. Okay, so let's say I want to do that here. Close. So then it's only for the button plate, right? What's if I want to move that here? Can I do that? Move object to. No, I can put it inside. I think it's something to do with that this tree represents the timeline. Rename, no. Tree settings. Select all instances appearance, random color, no. Was it placement? No, it's not placement because that's the location. I don't know. It's not the view, right? So I remember that there was a way to say, okay, please start inserting from that position, but add dependent object to selection. Let's see. So FreeCAD move var set to, I don't know. To the top of your tree view in FreeCAD, you cannot simply drag and drop it directly to first. Instead, you must use FreeCAD's native reordering command or structural workaround to shift its visual priority. But I thought, so I don't care about the visual priority, but I thought it's not only visual priority. So go to the tree view on the left. So let me move that over and just do it here. I'm on the tree view. Right click on your varset container, select move object or move selection. So we click here, move object, and there's no other move. Choose the target position at the very top of your project or active container. Move object to this. Okay, so that didn't work. Move object to this. No, that didn't work. If you're working with a part design body, the cleanest practice is to drop the var set directly into the body origin. Okay, but what if we have several bodies and so I'm wondering why this is not working. Let's just for a moment create another body. So now it's created after this. Move object to, and what am I supposed to click here? Group base. Okay, I don't know. Okay, so either we skip varset for a moment, or we watch a video or read more. So let's do this manually right now. So, okay, so we used an arc that was somewhere here. This one, right? Center like this. Boom. We said 9. And we said, I don't know, something like 90. Yeah. Or 180. I don't know. Let's use this and boom. Okay, then let's go here, say 9. And then go here and say here, like this. And then we go here and say 9. And then we go here and select this. Okay. So then I think we can just go here. And skip this one and that one. And this one and that one. And this one and that one. I don't know what happened to my cursor. Okay. Still okay. Probably because I'm on a tree view. So like this. So now we still have somehow lost some of the constraints. So we lost our length constraints. So can I say I want instead here and here? Ooh, that's not good. But I do want to take this one. Okay, so let's first try out what happens when I move it here, right? So, okay, so something like this. Okay, so can I take these two and say horizontal dimension? I cannot. Wrong selection. Select exactly one line or up to 2 points from the sketch. Okay. So let's use that on this and say horizontal and make it 100 exactly. Let's put it here. And then we use this on that and use vertical dimension and say 120. Okay. Now I have to say that I think these are symmetric. I think it's S. Is it? S. And this point and that point is symmetric. And these are symmetric. And this is symmetric. It's still not constrained. So, okay, I see. So this needs also be symmetric to this. And this needs to be symmetric to that. And this and that, right? So we still have 2 degrees of freedom. What's the degree of freedom? Okay, why can I move this? Because we didn't fix. Okay. Okay. And we need to fix this point and that point. Okay, so now it's fully constrained. Okay, got it. So this is quite a chunk of constraints, right? never mind. So fully constrained. Okay. So now we can say we want to pet that. And I think it's pretty thick here. We can go to the sketch, the other one to this one, and check what I used here. It's not the button plate. Where's the button plate? Here it is. And this should only select the plate, right? And here's the measurement, so 5 mils. Let's say 5. Okay, so we got a button plate. So now I'm not sure how to best do these things here without going crazy. Because one of the things we can, I don't know how to do, is let's see. Let's first try one. So go here and we just put another sketch on here. Right, and then basically it's just a circle. We just try it out. So we said it's 6 mils. Boom. And let's just put it in the center. Of course it doesn't work. Why can't I use that? This, okay, so because it's not equal, it's coincident, right? So okay, we got it. Then we could pad this out, which is what we want, right? Yeah, let's say okay, and then we want to take this face here and create a hole. Can we do that? Yeah. So the hole will then be something like 3. We don't care yet. So we don't want to drill an angle. And why do we have these things here? So let's say, okay, so okay. So then we can go in as far as we want, and then it goes outside the button plate. So basically we want to do this. And we could simply use it like this, right? So we could say this should be free. We can adjust that here. We can here say I'll just make it 1 or 2. Shift for fine dragging. That didn't work. I'm a bit lost. Failure while computing. Remove volume preview. Resulting shape is empty. How is it empty? Okay, cancel. Remove the hole here, please. Thank you. Okay, now it works. Base profile, circles and arcs. Head type, counter bore. Yes. So what did I do wrong here? So I can say 1 mil. And here, let's say something like this, right? If I say OK here, then we have it like in the original. Okay, so the question is, can I do it for all the holes simultaneously? And how? So let's go back to the sketch here and say, what about if we want to replicate this circle? So can we do that? What's this? Move array transform. Translate the selected geometries and enables the creation of. So that sounds good. Has no valid geometries. I need to be able to select this, right? And say that, okay. And I can say, so I need to press somewhere, do I? Okay, I could move it over. No, that was wrong. So I have to select the circle first. So let's say 2 times 2. Apply equal constraints. Okay. It's doing it. Copies 2 rows. Okay. 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 So let's try that again. We wanna copy 0, and that's not good, right? So if we say here and say copies 1, I can move it to there and can say, let's say 20 mils. Where's the 20 coming from? Okay. No clue. Okay, so this is only the, see? And then I still need to say, put the constraints here for 20 mils. Yeah, okay. And what's complaining about still 1 degree of freedom? Where has it? Okay, so it has freedom here. So I need to say something like, like so. Okay, fully constrained. Let's do it again. Okay, okay. Now we got 2 of these things, and best case, I want to say take this face and take that face and say make a hole, please, please. Ooh. Okay, then we can drill the holes through all the things. Okay. That sounds like it's going to work. Okay. So since that's probably fine, I think we should start with the button in the center. Also, can we Wow, I'm dropping frames like hell. What happens? Now we're back to normal. I don't know, give me a second. You can see my face for one moment, and I'm going to check what's happening here. Yeah, so we're sending, but it looks good to me. Constant. Okay. Who knows? So, right, so we can do that. Let's cancel this and go back to the sketch. So what we want to do is we want basically define, can we group something together and then make the array transform for the group, because not sure. So let's remove this one. Group constraint constrains the selected geometries together as a single entity. The position and size of the group geometries can be defined by constraints and construction. By constraining the construction line that is generated. Okay. I don't know. So, anyways, we set 6 millimeters. Let's try it out. So we want this to go away. We want to say copy, which of course does not work. Can I mirror offset array transform? Okay, so why not? So let's use a move array transform. We want to have 1 copy, 2 copies, 3 copies, or is it 4 copies then? And 2 of these, okay? Good. No. No. We don't want that. So we want just 1 copy, but 2 rows. Okay, let's go there. Say we want we want 20 mils here, 0. Okay, and then we want to have 30 mils here and 90. It's okay. And most likely it's better to say we do it like this, and we say 20 here and 30 here. Yes, like this, and then we turn the whole thing, and I could have done this from the start, I think, into construction lines. Then we say, we take that, we take this point and say, hello, like this. And why does it work? Both selected. Okay. So this one and this one, both selected, and now C. That's weird. Okay. Okay, and now I should be able to take these here, right? So now we use this and say group constraint. Does it work? Okay, and we got whatever. Okay, so let's see if that's going to be. So can I use that now and say boom and make 2 copies and 2 copies? I'm not exactly sure where I'm supposed to click. 2 copies and 2 copies, and let's say I'm clicking here. Is that okay? It seems so. So now it's giving me a perfect measure. And we should be able to go here and measure this distance. So we want this and that. No. So this is 34, and we want to subtract one of these, which is 6. So we go to 28 mils, right? Okay, and let's do the other way around as well. So we want this and, or this and this here. So this is 43. Come on, 43. And again, we want to subtract one of these things, which was 6. So we're going to 37. So 43 to 37. Okay, so we can say here, if I'm not mistaken, 28. Now, okay, and 0, Okay, and then we can say -37 and -90. Christ. And please let me click one more row. Oh, good. Okay, enter. So now I got this, but I didn't get the... Where's the rest of the geometry? Okay, so if this doesn't work like that, then we can go ahead and delete this. Is it possible? Oh, no. That's a group. Okay, so let's try to take this group. Boom. We want 2 copies and 3 rows. Right? So we want 28 and 0. And here we want 37 and -90. It's still doing only the lines, so that's not going to fly. It's unfortunate. How can I get rid of the group constraint stuff? This one here. I can get rid of that one. Okay. Then let's try it like this. Select everything here and do it again. 2, 3. -28 and 0. And 37 and -90. That doesn't look too bad. So, and now so if I select everything now and say group constraint, then I get one line. Why do I get only one line here? And if you think a bit forward, right, we need the position of the buttons for the cutouts and for the other plate. So we really do need a master thingy, a master sketch. And then these things could be in the master sketch, and I could just place the circles there. Okay, so why not take this and remove everything? Do cancel here? No. We want to create, this can go away. The sketch here is, what is that sketch? So this is the path. The sketch can go. We want to go here and create a sketch. Some of the features have dependencies in the source body. No. So what happens if I forgot to start the master sketch? I need to move it. Hide selection, toggle selectability, select all instances. No, no, no. Copy, delete, properties. Map mode, flat face, origin, that's all good. Can move it in there. I cannot move it up. I can move it outside. Can I move this down? No. Active body. A link is an object that references another object. Okay, no. Probably not what we want. Okay, so what if I create a new part? And then put the sketch in. That works. And put the button. So, okay, so that seems to work. So within the document, it's not possible. So let's say master sketch. Okay, let's open this one and say here we want to have everything is construction. So we got 100 and 120 like this. We still can move it around. So it should be enough if we say make these symmetric, right? And make this symmetric. Okay, so now it's fully constrained. Right, then we want rectangles for the buttons, which are 20 times 30. So and let's do the array transform again. So these are just lines. We want 2 and 3. And we want 28 and 0, enter. And then here we want 37 and minus 90, enter. Okay, so now I can just take each of them, but that's not the goal. The goal is to say let me give another try, right? So here I want to have these. I want to do this, apply equal constraints. What does that do? 2, 3. So 28 and 0, and here we want to have 37 and minus 90, enter. So is it now fixed? No, it's still not fixed. You can still move them around. So where are they equal? So I need to do these things, right? 8. What? So a horizontal constraint, please. It's L. Right. Yes. Okay, if I press L here, it doesn't work. Cannot find sketch or create fillet cons 2 times. It was L. Okay. Yep. Okay. Okay, so and then it should be enough to apply here one vertical constraint. No, it's not. No, it's not. Although I can take all of these here and say like this. Take all of these here and make them all horizontal. Then I have these all and these all. I will be over constrained, I think, at one point. Like this. So the vertical one is over constrained. Two degrees of freedom, which is X and Y, right? So I think for the symmetric, I can't do like this. I need points. And same here. Okay, so now it's fully constrained. The buttons are completely centered. Okay, and let's okay. So now we have the button plate. And we have a pad here. And I think we can do it like this. Click here and say binder. Can I put the binder above, please? No, I can't. like this. Okay. So now I got the binder here. I'm confused. I should see that. Maybe it must not be construction lines. It's better, right? Because now I see the binder, so it's not allowed to be construction lines. So if I go into the sketch here, say, don't highlight this. And now I should be able to say, import that, this, and this. Okay. Now I can close this. I got that one. So, and if I create a circle now of 6, of 6 millimeters, why is it not constrained? Why do I need to do that? So it tells me, okay, I'm going to, okay. Now it did work. 6. Now it's again, it's not. I don't understand it. Okay, let's try again. So we see the cross here. 6. Okay, so maybe I'm not supposed to put it directly onto it. I don't know. 6. Again, it's so GC, right? So okay, 6. Okay, so this is more or less painless, I think. That's okay. Okay. Fully constrained. Okay. So let's call this I don't know how to call this. Keyholes.
iViewers Streamboo.com.
Now we can pad it like this. And I don't know how tall we made these. 8. Was it the right one? Yeah. So let's do them. Define them as 8 mils. Okay. Looks good. Okay. And now the fun part starts, because now so this is the key stems. So now we want to have this, 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 and all these things. No. Okay, and for these we want holes, so please don't crash. Let's save first. Okay, looks good. Don't drill an angle. Okay, don't preview. Just show me. Counterbore. So the head diameter needs to be 1.75. And the depth needs to be, I have no idea, but let's see. Nine. Let's make it 9 millimeters. And the diameter here doesn't need to be 6, but much smaller. And I don't know how much smaller. So let's go here and find out. So this is probably still, so this has these things, and now we got these. .7, which is 0.85, right? 0.85. And this doesn't need to be more, so we got 5 for the plate, 8 for the thing. Should be, oh god. Stop it. I didn't even press that often. What's going on? So we're done now. So 5 for the base plate and 8 for this. So it's 13, right? Thank you very much. Now show me the preview, please. Why did it? Okay. So the head diameter was 1.75. 1.75. Okay, like this. It looks so small. Is it really? Yeah, it seems like. Ah, no, it's the diameter, not the radius. Okay. So this is 3.5. That looks more like it. And the depth is 9 mils. That's okay. Okay, so this looks kind of nice. That's okay, I think. Should we go for it? Okay. Please don't crash. Whew. Nice. So there are the holes down there for the screw. Oh, and I missed it. No, we need to go in there once more, because this diameter is 1.7 something. 1.7. Yeah, it was 1.7. This is also the diameter, 1.7. Okay. And that should be, I think I bought special screws for that. Let me check. Let me see. Yeah, so I believe it was these small ones here. very tiny. I think it's called M something, M1.6. Was it 1.6? Took me quite a while to find out the right size of the screws. I can't even show them because they're so small. Let me see. So this is how tiny they are. So and I think they fit perfectly into the stems of the keys. So where did I okay, I misplaced the key somewhere. I don't know. It didn't fall down. Ah, it's here. Right. Yeah, so this fits perfectly. Goes in there. So and just let's recheck the diameter here. Yeah, it's 1.8. I think I made it a bit smaller, but that's too small. Let's make 1.8 because let's make it 1.9. Okay. Boom. And this cutout is definitely wrong. It's not right. Because if the cutout here, if I look onto the original box, right, I placed the circle somewhere in between this. I don't know. It's not directly. I don't know. This cutout is not right. But that's something we can fix, right? Okay, so now we have this. So let me put the screws away. Okay, so we have this now. So So what's the best next step? Probably the bottom part of the box is the best next step. Yeah. Okay. So, and my plan with the master sketch is that we can reuse that. So we got the button plate, and now we can just say, great, we call that also ButtonBox. And now we can go ahead and can say, okay, make a new body. Let's call it, oh no, it's bottom case. Or we call it case bottom. So we can put that away, and now we have the master sketch and can design around it. So one of the things that I'm not sure how to do in FreeCAD, but we will find out how this works, is this here. Wait, is that here, right? So basically it's just a rectangle, but it's not. So it's like this, and I did it in two parts. So the first part, basically the upper half is only just a regular thing, and the slanted part, or so that it is like this, is just putting a triangle in the bottom part. So that's probably how we're going to do that. Let's see. Okay, so we got this selected, and now we want to say bring that also in, and we can hide this, and we can create a new sketch, also XY plane. No, we can't. Cancel. We need to create, oh no, that's the part, right? No, we were right. So we got a binder in this one. You can say master sketch with the binder here. Okay, so we want to create a new sketch. So I don't understand. Sometimes there's this dialog box with the selection of the attachment mode of the, so where basically where the sketch is attached, and sometimes there isn't. So okay. And maybe we should plan this out in the master sketch and just repeat it. So this is the one. I think the thickness I decided here is maybe 3 mils, and this is quite okay. It's 250. Is it really 250? Can I measure that? No, I can't, right? It's just cut out. Okay, let's first aim for 3 mils. And if we say 3 mils, it's 106 here and 126 here, right? Okay. So we got that. And then we can do first, we can say these are symmetric and this is symmetric. And then it's fixed already. Okay. And we can keep it a right angle inside and make it round outside, but this is for later. And so what we did before is basically place the screws or directly here, right? So we cut out a half circle here, and this is most likely not the best idea. Or is it? Let's take a circle here, center it here, and this is 6 mils, is it? So to know exactly what happens with the screws is we can take this one, can copy one over, ungroup that, and then go here. So this is 3 on both sides. So basically what we had is, what we would have is 3 mils. So that's what I don't want to happen is that basically the top goes off because it's breaking inside. And when I measure here, I think I have more than 3 mils. Oh no, I don't. Let's keep it like this. It's less here. Then it would be more sturdy than I had before. Okay. We will make a small restroom break. Give me 1 second. Right, and I remember why this is why this is probably not the best idea. So we have bigger holes on the top part because the screws basically go in there, right? So the screw heads go in there perfectly, right? Like this. So if you have the screw head, then it should be inside that one. So, and for that, we used 650, and this is not enough. 650, and if I say, okay, I want to have a 650 here, it's really close to the border of the overall case, and that's not what we want. So this is not what we want. So let's take this circle back and this circle back. Just say, let's create a circle which is 650 and think where we could place it. Where is that? Okay, so now I can move it freely. So it probably looks best if it's here, right? So this and this should have a dimension of here of 650. No, what? Oh no, that was wrong. So, and we can, does that look okay? So it's not even free. So what's the distance here? We got almost 4 mils between this, and this looks pretty nice here. No. Let's remove that constraint. Okay, and say, okay, so this point from this line should have a horizontal what? Yeah, this and this. Can't. Wrong selection. Select exactly one line or up to 2 points. Okay, so then we need to select that point and that point and say, okay, we want to have a distance of maybe 4. Okay, and then we do the same here. Select this and that and say it's a vertical of also 4. Let's see. That doesn't look too bad. Okay. And then we do the same here. So we got a circle somewhere here with 650. And what we want to do is we want to have the distance here of 4 and a vertical distance, a horizontal distance of also 4. Right. Okay. Next here. 6.5 and say horizontal 4 and let's do the other circle first. And then we do vertical dimension 4 and 4. Okay. So now we got the 650. And maybe we should let these 650 go through, right? Let's take the case here and disassemble it. So we got these things. This is 8 mils. Okay. Right. Then let's do another circle so that we remember that one. It's here and it's 8. And 8 is okay. It touches why? Why are you doing this to me? You said that it's okay. Christ. Okay, then another one. So, hello. So yeah, the cross is showing. There, the cross is showing. And I want 8. Nice. And another one here with 8. Okay. So we have that one now. Now we can say okay here. Go to that sketch. This is empty right now, but now we have all the fun stuff that we need. So basically here, yeah, okay. Let's save. And then we can import external geometry. So for that thing we need this, right? That's wrong and weird. I don't know what to do here. So why can't I get the whole circle? Now it's green. I can't get the other half, so I don't understand that. What? External projection creates an intersection of external geometry with the sketch plane. I don't know. No. I want the stuff projected here. But maybe we don't need this thing at all. We can just take that circle. We know it's going to be centered here. It's going to be 8 mils in diameter. So it's okay. We can try it out. So give me that circle and give me that one and this one. Okay. Gave me these points. Okay. Now we can go ahead and say here to here. Okay, good. We can take a polyline and say, let's start here exactly. Go to here. And then I think I can do M. So I got or I can just stop here. Go here, stop, start here, go here, stop, and start here and go here and stop. Okay, and then I can do a arc from center. Let's get it good. So we want this, we want this, and we want this. Why is it not? Why is it under constraint? So what is under constraint in that thing? Here. Why is that thing under constraint? Christ. So I want this and that, and I want these, and now it's over constrained. Christ. So 11, 18, 19, 20, 21. So this is that one. What's 11? But 11 is right. What? Okay, so now I should be able to say that. Oh, so, okay. No. Over constraint. What? Weird. Okay, let's try it again. So this should be here. And should be exactly 4. Enter. This is 90. This is 180. So we say here 90. And then we say minus 270. Okay, so that seems to fly. You can be very small. Basically, I don't want to see you at all. Okay. Let's try that again over here. So we used an arc with 4. So we start at 90 and go to, okay. We start at 90 and go to 270. Okay, that seems to work fine. Okay, another one. 4 mil and we start, for instance, here, which is 0, and go to, so we start at 0, and we go to, not 170, but 270. Okay, and then we take the last one, which is this one, 4 millimeters, and I don't know, let's start at 180 and go to it doesn't look too bad. Okay. Fully constrained. And we have okay, let's say okay. Oh, what's this doing here? Pad will not work. Oh, it does work, but it creates weird stuff. No. Cancel. So let's do that. And do this and do this. And I think we so we have these weird lines here. So what is let's see, okay. No, the lines are still here. So we need to get rid of all the construction, of all the external geometry. So this one, and this one, and this one. This one, and that point as well. And these here. And say, okay, construction lines. So it seems that this doesn't work. No. Wires not closed 2 times. Where is the wire not closed? Wires not closed 4 times. Hmm. I just saw a video recently where they said, or where they showed how this can be done, and I don't remember. Let me quickly check. I think it was here. Was it that one?
Continue working in part design, double-click on your main body in the tree view to make sure it's active again. Now we need to bring that path array into our body. To do that, we'll use the subshape binder tool. Simply select the path array, then trigger the subshape binder. You should see it appear as a transparent yellow shape in the viewport. Now hide the original path array, select the body and the binder while holding Control, and trigger the Boolean operation tool. In the task menu, just set it to cut and it's done.
Yeah, I got it.
You can generate faces from a sketch by checking the Make Internals box and perform extrusions on them. But you've probably...
Wait. That was too fast.
Object, whether it's a body, a sketch, or a specific feature, simply by pressing the space bar. It works both ways, hit space to hide, hit space to reveal. Once you get used to this shortcut, you'll never go back to manual clicking. Since version 1.1, you can generate faces from a sketch by checking the Make...
Okay, you can generate faces from a sketch. Internal geometry. Yes. Okay.
Make Internals box and perform extrusions on them. But you've probably been in a situation where you missed a few faces.
Okay. How? Okay, so what did he do?
You can generate faces from a sketch by checking the Make Internals box and perform extrusions on them. But you've probably been in a situation where you missed a few faces or...
So. So I want this one. Okay, so now I can, wait. Did he do the padding first?
You can generate faces from a sketch by checking the Make Internals box and perform extrusions on them. But you've probably...
No, he just takes it, then he clicks on it, and then he says, pad, perfect. This is what we want, right? Okay, good. So, basically the box here goes to 0. So the box overall is then we just cut something away. Yes. Okay, let's say 30 here. Okay. Okay, so and then we take this, create a new sketch. Can show our binder. Don't need to see that. Now we can go ahead and say just use this. Okay, fully constrained. Okay. And then we can pad further onto it. Exactly. $7.5. And then we can take this one, that one, can say, okay, new sketch, please. Like this. Show the binder. And say, okay, we want to have here. And basically, we want the line here, from here to here. We want to take this and this and this and that. Make it construction. Same here. This one. We want to make this and this and this and this and that. Also make it construction. Then we have these two things, and then we need another one which is like that. No. That. And that. And this. And this. And here we want to say symmetry. Doesn't work. But I still can take it and move it, right? Okay, it doesn't matter. What kind of thickness do I have here? Something like 4. And here. Okay, and then we should be also able to just say oh no, I can't. Okay, make that construction, please. And like this. And then we can take that, make it construction. Is there a shortcut for that? GN. Make a line here, make a line here. Okay. So it's fully constrained now, but I'm not sure what about. Okay, so let's see. Let's make OK and say pad. Perfect. And then we want to have let's make it 10. Okay. And now we need to take that. Oh God, let's see if that works. So you're going to take that make a sketch here. There should be a way to I need to see inside. Let me see inside. Toggle visibility. Okay, show selection. Toggle transparency. Okay, so that's probably what I want. Exactly. So, and then we can do, oh god, I hope that works. So we take a line strip, we start first let's take the outside geometry. We probably want this line. No, we don't want that. We want only that here. No, we need the other one as well. Okay. This and this. And then we can take a line strip and say we start here. Yeah. And we go back to here. Okay. So this is fully constrained. This and that needs to be like so. No, completely wrong, of course. Yeah. Let's start by drawing what we want to cut away and what we want to keep. So we start here. We go here. We go there. And we go back. So, and then we want this and that to be coincident, okay? Toggle transparency. And now I want to have, so pocket. Pocket, why is it closed 2 times? Why? What? Cancel. I did close it, did I? But also, I don't. What's that? Okay, so okay. So this here and that here is construction. Okay. So, and now we want to say pocket, right? Like this and through all. Why is through all so long? I don't know. To first, up to face, up to face, select face and use this one. Okay. That doesn't look too bad, except this can't be printed because we start here with something. We want to have this continue to the end. Can I just do that? Can I say, maybe not. If I select this, no, not that, but this. Okay, so no. We want, so this is the pocket. This is the pad. And the pad needs to include the other thing. I hope it doesn't crash because I'm doing crazy things right now. So make that construction. I know you're not happy. Construction. Construction and construction. So there you go, but we have and now we can say probably use that. It was 4, right? 4. We want to start from 90. And we want to go to 180. Minus 180. Okay. And we should be able to say remove that. And no. Okay, let's do the same here. Take an arc, use that one, 4, from 90 to minus 180. Okay, and then we can say, just put a new line here. Take this one and put it here. Okay, that works. Okay, same thing on the other side. Is the wire still not closed? Okay. We'll take care of that later. Construction. 4 mils from 90 to 180. What's going on here? So that one and this one should place. No, let's do it over again. Thank you. And another one here. From 90 to 180. Boom. And start here. And go here. Wire not closed 17 times. It's not good. So how can I have the pad here? Reference axis one side. Profile is sketch. So I want to do the pad here. Oh, that's another pad. Cancel. Okay, so fortunately I need to. Can I do that? Come on. Yes, I can. So let me. Yes. So now I want to have this sketch. Pad. Okay. And we had here, I don't know, 7? No, it wasn't 7. 1, right? 10. It was okay. It was 10. Okay. And now we have this. I can do sketch, say pocket. And we set up to face here. Okay. Right? So that's what we did. Okay, and finally, we can take this one and say, yep, make a sketch. Give me the external geometry. This one, this one, this one, and this one. Okay. And say pad with not 10, but let's say 3, 4, 3. Okay. Okay, so now we have that. What happens if I turn on? Ooh, the button plate is perfectly aligned. Nice. Let's give the button plate a different color. Appearance. Or maybe just the color. Line color, point color. Ambient color, close, okay. I don't know, stone? Looks good to me. Okay. So we have that. We need the holes in here. And I think so. Let's give these pads a name. Okay, so So this is the middle part, right? Middle part. Then that here is the top part. This is the bottom. And this is the cutaway. And then we have the floor. So what we need to do here is drill holes. And it seems to be that we're lucky here and it works, even that's not a circle. Nice. So then we can say skip the drill angle. The depth is, I have no clue. Let's make it, I don't know, let's check. So we can make it at least here, which is 3.5 mils. And the diameter is, I don't know, need to measure. Three. Maybe 3.1. What we got here? Oh no, this one. Let's take that, ungroup it, and then see what we have here. 3, exactly 3. So that would look then like this. Perfect. Okay. And can I add faces to that? I don't know. Let's see. Let's make OK. Go to hole here. Where does it store profile? Bottom floor face 15. Link is can I just add more? I don't know. Let's try it out. Okay, we got that. No, that doesn't work. Wait. I want to add something here. Sync sub-object selection. Okay, let's try it again. So we want this, we want this, we want that, and we want that. Sync. How can I do that? I was also in the video. It was also in the video I watched. Let me see. No. Maybe that.
To any geometry, no plane, no face. To fix this, go to the Sketches Data Properties. Under the Attachment section, you need to select a plane or a face. Since we don't have a face here, we're going to choose the XY plane and click OK. After that, the symbol should disappear. You'll almost never see this happen in part design, but it pops up quite a bit in the part workbench. If your sketch doesn't have any icons at all, then everything is perfect. It's fully constrained and properly positioned. To respond to Xana, yes, you can have a grid with snapping, but it's not the default behavior. When you've created a sketch, you need to instead launch the fillet tool first. This activates a selection mode where you can simply click each edge one by one without holding any keys. It's safer, faster, and much less frustrating. When you create a fillet or a chamfer, it automatically propagates to all tangent adjacent edges. The thing is, in FreeCAD's fillet options, there's no way to stop this behavior, unlike in Fusion or Plasticity, where you can just toggle it off. Here we have to be smarter than the solver and do it ourselves. You need to create a circular arc matching the fillet radius, but for now, 8 variable fillets models directly to your favorite way macro, which, yes, you can actually model the threads that tolerance class complex parts, the through hole, but with threads only complex parts. You know that fillets can be unstable operations and often lead to recomputation errors. For example, here I have a solid and no longer depends on the geometry, the feature, and select Move Feature After. In the window that pops up, just select the last operation before the mirror and click OK. Then simply make the equivalent of moving the playhead in Fusion will be inserted right there between that operation and the mirror. You can then create your sketch on the pad. In this pocket and recomputing the object, you can see it no longer appears after the mirror. This action is reversible. If you ever need that operation again, you can just unsuppress it and it will reappear instantly after a recompute. Section Analysis tool. However, you can easily install from the add-on manager. Create multiple solids within a single body in part design. Act as a cutter. It's vital here to place the cutter or the solid you want to array exactly on the axis origin, as this position is what the path is or the spacing go to. Now hide the origin between workbenches, like we just did. Laggy and not very...
No, I don't know. Okay, so wait, I got a hole, but I can't see, so I have a hole here. It's perfect and okay. So if suppressed face, edit hole, move feature after, set tip, no. Properties, I think that's the properties, right? So how does this work? Link. Okay, so there's link. Okay. Link actions. Make link. No, don't want to do that. Okay. So I don't know how to do that now. So now I want a hole. I want it we set 3.5. No, that's too long. Diameter is 3. No angle. And I think 3.5 is too much. So let's make it 3. Okay. So then this is screw holes. And now for the nicer things, we could say chamfer. Like this. Okay. And we can say use that. That, this, and this. Make it 3 mils. And this looks weird. Can't put it down, right? Before that, no. Okay, so for the moment we will keep it like that. Okay, so we got that, and the thing that's missing is basically only the top part. So this one here. Okay. But that one shouldn't be too bad now that we got the rest going, right? So we need to adjust this one here, the angle down here, this one. We can do that before, I think. So button plate, and the pad depends on this sketch, and I want to see the binder. Okay, let's bring that in on this and this and this. Okay. Oh no, wait. Let's bring it in as construction geometry. Then we don't have to. And this, okay. I hope won't break everything. So let's go here. That can go away and this can go away. So and then we just say make a circle centered here and here. Will this be too big? Let's see if it will. Right, okay, let's do it like that. And then fix the rest in a second. It's over constraint, okay. Then so this is under constraint, that's okay. And now we just want to say that this one is definitely this one is so let's see what I can move here. So this is weird already. These points should be together. So what can I move now? Now it's okay like this. The only thing I need to do is Oh, this is still not connected, is it?
Someone's up early. Sun face.
Yeah, I'm not early. I'm still going. Good morning to you. So this one is supposed to be okay. Now it's still not doing its thing. Okay, we go here, we go there. So yes, it's over constrained. Okay, then we need to make this with angles, I don't know, a different way. So, okay. We can't do it with angles, can we? Let's do here 110. That's too much. 100. That looks okay. So now I should be able to say, give me an arc from here to here. Okay, so this is good because that's green. Now, the only problem is doing it for the rest of the arcs as well without breaking anything. Go from here to here. Okay, it's not doing. Something is not, I don't know what. Can't move anything. Okay, then doing the same here. Okay, and doing the same here. So there are obviously 3 degrees of freedom, and I don't know why. What's free here? Because nothing is free here. Oh yeah, so this arc is free here, and how can I fix that? So I could say this and this. So wrong selection, okay. That point and that point. Or maybe we do simpler and say this and that. Okay, so the points, I don't know, I don't get it. So this one and this one, same deal. And maybe we're lucky and see the same here. Right, so this one and this line. Okay, fully constrained. Perfect. Okay. Now, Okay, so that was too much wiggle room, but we should be able to simply say, let's decrease it a bit by going here and say, let's make it 106. Okay. So perfect. Now it should fit the overall thing. Nice. Okay, before we forget this, let's go back to that and say, here we don't want 100, we want 99.7. And here we don't want 120, but 119.7 to give it a bit of wiggle room so that it fit inside. Oh, okay. Hide the binder, show me the case. So now we got a tiny bit of wiggle room for the print. Perfect. All right, so that being said, that's it for me. Thanks everyone for hanging out. Was a great pleasure not to be alone and sit through this. Maybe I start a test print and then we can see if it really fits or if we are screwed up somewhere. Yeah, and the final step is then to simply design the other thing that I have in Tinkercad, which is the top of the box somewhere here. Yeah, this thing. And we will basically design this and that in one go. We can get the font on top in a different way. We don't need this cutout here. We can do it in one go. And then it's only a 3-part box. So, okay. See you everyone. Have a great morning, night, or day.